factors, 8 being, 1, 2, 4, and 8, 24 being 1, 2, 3, 4, 6, 8, 12, 24, 1, 2, 4, 8, and 16, and finding the number that's greatest amongst that set of numbers. So in this case, it would be, in fact, the 8. Let's say I added 12 there, a 12 into that list of numbers. 1, 2, 3, 4, 6, 12. I lost the 8, so now my greatest common factor would be 4. Okay, and that's all we're looking at there, just kind of greatest common factor. Now, you can use that with variables as well. So let's say I had x3, x5, and x. My greatest, or let's say x2 here. My greatest common factor amongst these x's is an x squared. Okay, it's the highest amount of exponents that's available to factor out. Okay, so you can factor out, and let's say I had x3 plus x5 plus x2, and I factored out an x2, it would become x plus, because I'm dividing, you're subtracting, 5 minus 2, 3, x2, x2, x2 over x2 is actually 1. So that's how I can factor out with exponents. Let's say you're given a polynomial with a set of, we've been working unfoiling, but we look at this polynomial here and we say, okay, I don't have the x squared I'm used to working with, or a b squared that I'm used to working with, and the numbers look pretty large, and this is going to be hard to find factors for 70 and 280 to find some sort of unfoil. So what I could do is, okay, let me come up with a greatest common factor. I look at 70, 165, and 280. I recognize they either end in 0 and 5. So I know just kind of, math IQ there is just knowing that, okay, any number that ends in 0 and 5 is going to be a factor of that number. So I can attempt and try, okay, I have factoring out of 5. Now these are negative, so if I want my beginning or leading coefficient and my highest degree to be positive, I may want to factor out a negative number. So I have the 5. Now I also look at the b's. I have a b to the 5th, b to the 4th, b to the 3rd. So my greatest common factor amongst these three terms is a negative 5b to the 3rd. And that allows me to factor out and get a 14b squared minus, I think that's 33b. Well, actually, if I'm factoring a minus from a minus, that'd be a positive. And a negative 56. Now, this looks a little bit more familiar as far as having the b squared, having some lower numbers to work with in case I want to, like we say, unfoil this, right? Because we're trying to factor here. Notice that the b third and the b third factored, and there's no longer a b third here. So I'll list my, best way to do this, I know you guys are asking about this, is to list my factors for my first, which is what this is, 1, 2, 7, and 14, and list my factors for my last. 1, 2, now I'll match up the 1 and the 56, 2 and, what is that, 28? I don't think 3 is going into it. You have 4 and 14. You can add a 7 and an 8. These are all your factors. 1, 2, 4, 14. Now I have to find some combination. Okay, let's leave this alone for a second. Let's look at these parentheses here saying, okay, if I use, I know this is a negative here, so I'm going to have a negative and some sort of positive here. And if I use a 2 for my first, so let's say I do 2b, I have to use the matching, no, actually, I would have to use the matching 7, you're right. I was looking at the wrong list there. Now, I want a 33b, so I want a pretty decent sized positive number. That's what this 2b and this number is going to give me here. So I can look at, okay, if I did 2 times 14, that's going to give me 28. That number's not high enough for me to combine it with a negative number and get to a 33. So let me try 2 and 28. All right, so I'm using, and if I use a 28, I have to use a 2. And let me use the 7 and the 2. Now what I look at is I look at my outside and my inside to combine and give me a combination of 33. So here I have negative 14b and I have a positive 56b. Right? And if I'm combining these two and I'm finding the difference, basically I'm doing 56 minus 14, which would give me a 42b, and that's not what I have here. Right? So if we're looking and testing a little bit forward, okay, let me look at something different here, like
4 and 14.
Let's keep the 2b and the 7b. You want to try 4 and 14?
Yeah.
2b and the 7b. Let's try, well, we want the bigger number to be positive. So if I put the 14 here, think about it, you're going to end up with somewhere in the 90s or hundreds, right? So, and then you're combining that with a 4, which is 8. So that difference it's too big of a difference. We're trying to get to 33. So let's get some numbers that are a little bit closer together. Let's look at a number like 7. They have here 7 and a 7b, right? Which gives me about, that's a negative 49. Let's make it positive, a positive 49 with a negative 16. And where I'm getting that 49 to 16, I'm getting that from combining a negative 16b and a 49b here, my inside and outside. Okay, a positive 49b and a negative 16b will in fact give me that positive 33b. Now you might have to test that 4 and the 14. You might have to test that 2 and 28. Now I've actually was able to unfoil this here. Now another thing I could do is to say, okay, we have the negative 5b to the third. We've unfoiled this. 2b plus 7. 7b minus 8. Now this unfoil could be work intensive. It could take time. It's not something that you could just find the pieces to the puzzle and it works out. This is something that you may have to experiment and trial and error, check and adjust quite a few things until we get this here. Now, we've picked a problem with very high numbers, so this is probably as intensive as it will get, but just to show you what it would take to get this here. Now, you're looking for your zeros. Let's say we want to take this one step further, right? And we're looking for real roots like we've been talking about. And you want to just take it and look at zeros here. Okay, where will my graph intersect the x-axis? Well, if I set it equal to 0, I know one of my zeros is going to be 0 itself, because if I put a 0 here, 0 to the third power is 0, And then as soon as I have a 0 and I'm multiplying, 0 times, doesn't matter what this is going to give me a 0. So one of my zeros is actually a 0. This graph will actually intersect at the origin. Now I want to solve for 0 here. 2b plus 7 is equal to 0. 7b minus 8 is equal to 0. Minus 7, 2b is equal to negative 7. One of my zeros is in fact negative 7 over 2. And then add 8, 7b is equal to 8. One of my zeros is 8 over 7. 8 over 7. Now this is a problem that has a high degree exponent. You could use this. You could use this in a simpler problem, right? Where you just have the exponents. You just have the exponents here, right? And you're looking at these numbers and you're looking for the greatest number. So I know 8 doesn't go into this, right? Because 8 times 12 is 96. So I might want to go a little bit lower and test out 4. Now let's say you use 2. That's a good point. Let's say you use a negative 2 here, right? And you get negative, or you'll get a 40c minus, what is that, a 46 minus a 12. What do you notice? Still even numbers, okay? So actually I could have factored a little bit more there. You can tell right away. You'll know you found the greatest common factor when you factored out these values, and it's completely simplified. It is as reduced as you can get. Yes.
Could you still use the negative 2?
You could still unfoil this using the negative 2, but that's going to make things a little. So if I go a little bit further and use a negative 4, okay, now I have a negative 20c squared. I have a negative. What is that, 23? 23c and 6. This probably should be positive 6. That should be positive, and this should be positive since I factored out a negative. Right? If I factor out a negative 4 from these terms, when you factor a negative from a negative, it actually makes it a positive. It's like you're dividing a negative in a negative.
So 46 and 12 should be positive?
Yeah, right here, 46 and 12 should have been positive. Absolutely. And then your first, I have a 1, 20, 2 and a 10, 4 and a 5. My last, I have a 1, 3, 1, 2, 3, and a 6. And I'm looking for a 23, and it's positive, right? I have a positive. This is actually a little bit easier because the signs aren't different. So I want to make somehow a 23. So if I use, so I'm looking at this, if I'm using a 2, I'm using a 10. So if this is 2c, I'm going to use 10c. And then the 2 and 3, this would give me a 20, and this would give me a 6. That gives me 26. I don't think that's going to work. So let me try 4 and 5. 4 and 5. So you want to do a 4c, 5c.
And then you can try the 2 and the 3 again.
Try the 2 and the 3 again. That gives you a 10. That gives you a 10 and a 12. So that's a 23, which is closer. What's your suggestion?
That's a 22. That's.
Yeah, it's not. We're not quite there yet.
Are you gonna try the 1 and the 6 then?
With the 4 and 5. 1 and 6. That gives me a 24 and a 5. If I did 15 and 8. 8C, 15C, 23C. And now 4C plus 3, 5C plus 2. Now, yeah, there's still some work, there's some puzzling, there's some solving that you need to do, but this is a lot easier. This is a lot easier than trying to unfoil this. Now, a lot of times too, what you could do is you could put this and use your calculator, and instead of making a list of greatest common factors, you could just start dividing 80, 92, and 24 by numbers, and you could just probably speed up the process. Okay, let me use 4. Divide, divide, divide. Oh, well, my numbers aren't as low if I use the 2. Then use the 4. Let's say you try to go a little bit further. You try to use an 8. Oh, 10. Uh-oh. Decimal doesn't work, so I got to go backwards. And then you could also put this into a graphing calculator and just, you could actually put this into a graphing calculator and then see one of your zeros as, here's a cheat. You could see one of your zeros. Let's say I did -3, -3, 4C is equal to -3, divide by 4, divide by 4. And you see one of your zeros is -3 over 4 or -70, -0.75. You would know that 3 and 4 actually have to go into one of your parentheses. If you really got good at it and you saw, oh, I graphed it, I used my calc function and I found a 0 and I found it to be -3 over 4, well, I know if I reverse the -3 over 4, I would get a 4C plus 3. You can actually use that to find a piece of your unfoiled.